joining me on Fascinating Frontiers, episode 143, coming to you on July 26th, 2026. Let's look at what's new across the frontiers of space and science. 3 astronauts are heading home after 241 days in orbit, while Juno reaches its closest approach to Earth. Soyuz MS-28 undocked from the International Space Station Rassvet module at 3:02 a.m. Eastern Daylight Time. The spacecraft carried NASA astronaut Chris Williams along with Roscosmos cosmonauts Sergei Kudz-Sverchkov and Sergei Mikhaev. The crew had spent 241 days in space before the separation. A 4-minute, 42-second deorbit burn began at 0931 UTC. Touchdown in Kazakhstan is scheduled for 10:25 UTC. Command of the station passed to astronaut Jessica Meir before departure, marking the end of Expedition 74. Now shifting to commercial launch developments. SpaceX plans a tower catch attempt on the next Starship flight. Elon Musk stated the company will attempt to catch the upper stage with the launch tower on Flight 14 unless post-flight data review reveals problems. The decision follows Flight 13's successful upper stage splashdown. The booster from Flight 13 already demonstrated controlled descent and landing burn performance. Tower capture would eliminate the need for downrange recovery vessels. Engineers will review telemetry from the recent flight before committing hardware to the new profile. Remember, we covered Starship development yesterday, and this step directly advances the rapid reuse cadence that remains the central open question for the program. On a different note, asteroid 3 Juno reaches opposition in Aquila. The 9th magnitude asteroid becomes visible all night as it lies opposite the Sun. It already sits above the horizon at sunset. The Moon lies nearby in the same constellation. Observers can track Juno throughout the night with modest telescopes. Opposition places the asteroid at its brightest apparent magnitude for the year. No special equipment beyond a small telescope is required for detection. Turning now to exoplanet atmospheres. JWST may miss water hidden deep in mini-Neptunes. Sub-Neptunes make up the most common planet type yet detected, with nearly 3,300 confirmed. Their thick, hazy atmospheres block transmission spectroscopy even with JWST. No solar system analog exists for comparison. High-altitude clouds or photochemical hazes are suspected to mute spectral features. Longer wavelength observations may eventually reveal water absorption bands that current data cannot access. The Cosmic Spotlight looks at these JWST findings in more detail. JWST observations of sub-Neptunes are revealing how thick, hazy atmospheres can hide water vapor even when the molecules are present deeper down. The 3,300 known examples lack a solar system counterpart, so models rely entirely on remote data. Transmission spectra show muted features that could indicate high-altitude clouds or photochemical hazes. Multi-wavelength campaigns may detect water absorption at longer infrared wavelengths where haze opacity drops. Laboratory simulations of hazy atmospheres are now being compared directly with the telescope spectra. The next step involves stacking observations across multiple transits to improve signal-to-noise at those key bands. Next up, an exoplanet that survived its host star's death. Astronomers are examining a world that remained bound after its star evolved into a white dwarf. The survival offers clues about orbital migration and tidal forces during stellar expansion. Follow-up spectroscopy will search for atmospheric changes induced by the star's final stages. The planet's current orbit lies close enough for ongoing tidal heating. Its atmosphere may show traces of material accreted during the red giant phase. Shifting to another nearby system, Barnard's star planets appear inhospitable yet informative. The system contains multiple planets but none in the habitable zone. Researchers note the worlds can still constrain formation models around low-mass stars. Continued radial velocity monitoring aims to refine their masses and orbits. The planets orbit a red dwarf only 6 light-years away. Their close-in paths subject them to intense stellar radiation. Moving to a rare transient event, A rare blue optical transient was found in a dwarf galaxy. Chinese astronomers detected AT 2019I-JN, a fast-rising, slow-decaying event with unusually bright radio emission. The transient occurred at the center of its host galaxy. Its properties do not match known supernova or tidal disruption classes, suggesting a possible new explosion mechanism. The optical light curve peaked within days before fading over weeks. Radio observations revealed sustained high luminosity inconsistent with standard models. On the technology side, a commercial camera could aid LIGO black hole searches. The approach would monitor auxiliary optics without requiring new hardware development. It targets stray light that currently limits sensitivity at certain frequencies. Early tests show the method could increase detection rates for merging black holes. The camera would operate continuously alongside existing interferometers. Off-the-shelf components keep costs low while addressing a known noise source. A gram-scale probe concept is also under discussion for a nearby black hole. Cosimo Bambi of Fudan University outlines requirements for sending a small spacecraft to a stellar mass black hole. The probe would measure strong field gravity effects unreachable by remote observation. Travel time and communication constraints remain the primary engineering hurdles. A gram-scale design reduces launch mass and radiation exposure during the long cruise. Laser or radio links would need extreme precision over interstellar distances. The Cosmic Deep Dive examines how black holes slowly evaporate. If the sun were compressed into a black hole, its event horizon would span only 6 kilometers yet contain the mass of 2 octillion tons. Virtual particle pairs constantly pop into existence near that horizon. One falls inward while the other escapes as Hawking radiation, carrying away energy. Over time, the black hole loses mass and its temperature rises, accelerating the process until the final stages release a burst of particles. A solar mass black hole would require roughly 10 to the 67 years to vanish completely, far longer than the current age of the universe. The radiation spectrum follows a perfect black-body curve whose peak wavelength shrinks as the hole shrinks. We can calculate the spectrum of this radiation in detail, but nobody knows whether the information that fell into the black hole is truly destroyed or somehow encoded in the outgoing radiation. Turning to a human story from station operations, Michael Foley recounts the 1997 Mir collision response. Foley describes how crewmate Alexander Lazutkin accepted full responsibility for the Progress collision. The crew worked to stabilize the station after the impact. Foley states the team saved Space Station Mir that day. The account appears in the PBS series Once Upon a Time in Space. Lazutkin's decision to take blame helped maintain crew cohesion during the crisis. A podcast marks the 50th anniversary of the Viking 1 Mars landing. Episode 220 of This Week in Space features astrobiologist Penny Boston and planetary scientist Pascal Lee. The discussion covers the first successful soft landing on Mars and its scientific legacy. Viking 1 touched down on July 20th, 1976. The lander returned the first close-up images of the Martian surface. Its biology experiments searched for signs of life in the regolith. Chushiro Hayashi's 1920 birth is also remembered this week. Hayashi applied nuclear physics to stellar evolution after wartime naval service. He later became a professor at Kyoto University and developed the Hayashi track for pre-main sequence stars. His work remains foundational in models of star formation. The Hayashi track describes how contracting protostars move across the Hertzsprung-Russell diagram before reaching the main sequence. His calculations incorporated realistic opacities and convection that earlier models lacked. Modern stellar evolution codes still reference his 1960s papers as benchmarks. A 74-year-old telescope recently captured an image of Saturn. The Soviet-era AVR-1 instrument, built in 1952, produced the photo under current amateur conditions. The result demonstrates the continued usability of mid-century optics for planetary imaging. Observers used modern tracking mounts and cameras attached to the original tube assembly. Saturn's rings and cloud bands remain visible despite the telescope's age. The image highlights how accessible planetary photography has become, even with legacy equipment. NASA and ESA facilities avoided major wildfire damage in Spain. Ground stations operated by both agencies escaped serious harm from the fires. Assessment of any minor effects will occur once access is restored. The sites support deep space communications for multiple missions. Operations at the complexes continued without interruption during the event. Engineers will inspect antennas and support buildings when safety permits. Before we go, keep an eye on upcoming Starship flight data that will decide whether the tower catch proceeds on Flight 14. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. One more thing, if you liked today's episode, our sister show First Principles Daily is worth a spot in your feed. Reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. It's one of the Nera Network's daily briefings, all free at neranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at neranetwork.com/thedppod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through